A mold is a material with negative hollow cavities of desired shape into which a liquid is poured, which later solidifies, taking the same shape as the mold. In this video we are going to make molds from silicone liquid which hardens to form rubbery solids with 3D printed parts I designed with SolidWorks software, acting as masterpieces to form negative hollow cavities into our hardened silicone molds. Now I started by applying hot glue onto the bottom of each 3D printed part so that it gets stuck firmly onto the base holding surface, which in this case is the glass panel I used. This will help the parts not to float when in liquid silicone. Please note that you should apply a very thin hot glue layer on the bottom of each part so that not to affect its general dimensions. The parts are arranged on the glass panel according to their height, and make sure that all the parts are firmly seated on the glass panel, as you can see. Thereafter, I arranged some pieces of wood to make a simple box to be used to form the external boundaries of the silicone molds. I applied hot glue on first the four corners of each box to hold them to stick on the glass panel with the 3D printed masterpieces inside the boxes. Then I had to fill the bottom of these box edges with hot glue to seal them and prevent any liquid silicone from leaking out when being poured into the boxes. Now at this point, we should note that silicone is very expensive to acquire, especially here in Uganda, where a milligram of liquid silicone is sold at around 200 shillings. That's around $0.0541 US. Therefore, we have got to know the exact amount of silicone we need to avoid excess, which will amount to wastage. Silicone liquid comes into two parts which you mix equally for it to cure or harden. Please note that all silicone measurements should be in mass and not in volume. So all we have to do is get the total volume of our boxes where mixed silicone will be poured. In my case, I was using a tape measure to get the length, width and height, which amounted to the volume of each box, the total volume being the sum of volumes for all the boxes, and then multiply that volume with the density of the silicone, which is around 1.2 grams per cubic centimeters. This will give us the total mass of silicone mixture that we need. But because silicone comes in two parts, therefore we have to divide the total mass by 2 to get the mass of each silicone part to pour into the mixing container. We now get our handwear protection gloves, a mass weighing scale. I used a digital version to achieve better accuracy. I then got a mixing plastic container which I placed on top of the paper sitting on top of the weighing scale. This paper will prevent the liquid silicone from dropping directly on the body of our scale, keeping it clean. Now after putting everything on the scale, I reset it for it to read 0 before pouring silicone into the mixing container on top of it. After resetting the scale, then gently pour equal amounts of each part of silicone from every container into the plastic mixing container. Here I think we have to pour around 330 grams of silicone from each container part of silicone. Now please ensure accuracy accordingly, otherwise the silicone won't cure and solidify to harden. Thereafter, stir the silicone mixture thoroughly and make it ready to be poured into the wooden boxes bounding the 3D printed parts that will form cavities into the silicone when it cures and hardens. Gently pour the ready mixed silicone into the boxes over the 3D printed parts until they are all merged into the silicone while removing any bubbles from it. Now leave the whole setup in peace so that the silicone cures and hardens. After patiently waiting for about 24 hours for our silicone to harden into a solid, it's time to remove the wooden boundaries from the hardened silicone. I used a sharp edge to separate the wooden pieces from the silicone, and please take care not to tear or cut the silicone with that sharp edge you're using. Then I used a pair of nozzle pliers to separate and break off the wooden pieces from the hardened silicone. Thereafter, it was time to separate the silicone from the base glass panel. Now, hardened silicone is very flexible, and the other important property with it is that it does not stick to almost everything other than itself. As you can see that the 3D printed pieces easily come out of the silicone material without applying any greater effort. Now that is so because silicone did not stick to them. Now also take care not to tear the silicone molds. Try to press and flex the silicone mold in order to make the 3D printed masterpieces to separate from the silicone. Then after, just pull out the masterpieces, as you can see. Then after removing all the 3D printed masterpieces from the silicone which left their cavities, I tried to scissor cut the boundaries of silicone in order to make it look somehow nice. This is how I managed to make a simple mold using silicone liquids. In our next tutorial video, we'll see how to make the exact replicas of the 3D printed masterpieces by pouring liquid epoxy resins into the cavities in these silicone molds. Once again, I thank you for watching this video from Binge Inventions. Please like and share to your friends these videos, and also subscribe to our YouTube channel to get more from us.